2.1. So solving rational equations. Now, when you're solving equations in general, so you started off with kind of linear equations, probably even in elementary school and in grade 9. Then you went on, you had some quadratics that you were able to kind of solve, which led on to polynomials, okay? And then slowly, these equations get a little bit harder. Now, don't feel bad, because some of the equations are actually kind of tough to try to solve. If it falls in a particular pattern where, you have an equation and it leads to something which is linear or something which is quadratic or higher order polynomial, but it's still doable in terms of factoring, then okay. But most of the time, if you do have the order of your polynomials getting higher and higher, then it just gets super hard. And most of the time we'll use some kind of graphical tool or some other tool to solve for our equations or our unknown. Now, when you're dealing with rational functions, so I have 3 examples here. So you'll notice that you may have both, a polynomial on top and then a polynomial at the bottom. Okay, so in those instances, it gets even further in terms of hardness, because of the fact that now you still have to manipulate these equations to try to see what you can do. All right, so I'm going to take up these examples and then I'll show you, just to give you some kind of a gist on how to approach these rational equations and then solve for the unknown, whatever it might be. Okay. Now, for polynomial equations and solving those, you can take a look up at the video, and I think it's worthwhile to watch that one first before you jump into these. But I think you will get the essence of how do you approach these particular equations, and I'm going to literally do it through example just so that you know. So our first example that you see there, whenever we're dealing with rational equations, we always will have to think, okay, well, for certain values for rational equations, the solution just simply won't work, because we don't want to have undefined in terms of the answer, okay, making our left-hand side or the right-hand side in some way undefined. So for example, 1 over t, we know that we can't really have t equal to 0, because it would be 1 over 0, and then the whole thing falls apart. The 1 over t plus 5, so that means that t can't be -5, right? But everything else is kind of fair game unless they restrict this equation for us. So, I will take this equation and let's take a look and see how we can work with it and then solve it throughout. Okay, so here it is. So we are saying that we certainly cannot have t cannot be equal to 0 and t cannot be equal to -5. All right, so that's the first thing. Now, our unknown is in the denominators, and not only that, we have kind of a fraction form of this rational on the left-hand side, and then we just have a number on the right-hand side. So I'm going to start manipulating these, right? So first of all, so if I take the left-hand side right here, and I find a common denominator between them, so that would be t and t plus 5. Okay, so in that case, what I will get in this case, so this is going to be so t plus 5 times this 1 is going to be t plus 5 plus t times the 1, which is going to be t, and then on the right hand side I just still have 8. Okay, now simplifying this, that means in the numerator, I'm going to get 2t plus 5. And then in the denominator, what I will have is just t and then t plus 5, as so. Now, I don't want to have a denominator whenever I am solving equations. So what I'm going to do, whenever you do have your unknown, okay, in the denominator, so in this case, I want to get rid of it. Okay, so I'm going to be multiplying both sides by t, t plus 5. So if I do that, so if I say t and then t plus 5 on this side, so this whole thing will cancel. But of course, I have to also multiply it on the opposite side. Okay, and I'm going to get that, which now basically transforms this into polynomials, right? So I have 2t plus 5 is equal to, now I can take this, expand it, and simplify it. So that's going to be, so in this case, this is 8, so it's going to be 8t squared. All right, so that's for that. So I'm just distributing that across there, plus then 8 times 5, which is 40t. Okay, so this is what I would have. So clearly, this is now just polynomial, and it goes back to, okay, can I solve polynomials? So I can bring all of these to one of the sides. So let me move this one over to this side. So it's going to be 0 equals 2, 8t plus, okay, so this is going to be plus now 40, and then this is going to be minus the 2t, so that's going to be 38t, and then I'm going to have minus 5, okay, coming from right here. So looking at this now, if I want to be solving for t, well, this is just a quadratic, right? So at the end of the day, you know, so I have 8, I have 38, and then negative 5 right here. I have my coefficients. I know it's a quadratic. I can apply my quadratic formula or factoring, whatever it is that you like. I typically, you know, because I don't like that 38 there, okay, so, you know, I most of the time I would just go ahead and just try to use the quadratic formula, but if you want, you can certainly use factoring, okay, if it's possible. So let's see if a solution actually exists here. And so I'm going to do this in fast forward fashion by, you know, utilizing, okay, this is my quadratic formula, and so I'm going to put that in here, substitute my coefficients, so my a, my b, my c, and then see what I get, okay? So let's do that, okay? All right, so welcome back. So after the quadratic formula, so notice factoring would have been annoying. You know, we get decimal results. So, you know, it's approximately 0.128 and then negative 4.8, you know, 78. So those are my two answers. And these are just zeros of that particular equation, so that quadratic. So you can always check for yourself, because what do those zeros mean, right? So if we take out, and I take out, let's say, you know, decimals or any other tool that you like, I can always plug this in, okay, and graph it out. Minus 5, so let's see what this would be. And sorry, this is, so I used t, you know, so let's put f of t equals, all right, so notice that, you know, here's our parabola, so here is the answer of negative 4.878, so that's what we got, and then the other one, which is 0.128 approximately, so those are just my zeros. So that's how you can approach these, so it's just manipulating throughout. And this one, because it was quadratic, we could actually solve without a lot of, you know, worries. Let's take a look at the second example that we have here. So I'm going to take this copy, let's bring it back down, so paste it, and let's work with this one now, and let's see what would happen right here. And so now starting off again, so it is rational, so I have these two right here. I don't really want them, so what I'm going to do is I'm going to be multiplying both sides. So let me get rid of this thing, okay, and then get rid of this thing. So I'm going to get y minus 2, so that's this numerator right here. So this is going to be multiplied, so I'm going to kind of cross multiply through here, so get rid of that from the right hand side, and then 5 is going to get multiplied by 3 plus y, all right? So that's kind of through the cross multiplication, or multiplying the left hand side by 3 plus y, so that's going to cancel the denominator, and you have to do that to the right hand side. And then you have to multiply the right-hand side by 10 minus 3y, which is going to cancel that denominator, but then it's going to appear on the left. So from here, once again, we are noticing that, oh, okay, you know, it's kind of nice, but it seems complicated. So I'm going to kind of distribute this across. So 10y minus, this is going to be 3y squared right here, minus 20 plus, I guess, 6y. So that's on the left-hand side. On the right-hand side, let me distribute this. So that's 15 plus 5y. And now I can just collect all the different things and put them on one side. Now, which side you decide, it doesn't matter. Okay, so you can put them on the left or on the right. I'm actually noticing, so notice this is going to be another quadratic, but I have a negative here, so I'm going to move all of these to this side, right? So it's going to make it 3y squared. I just like it positive. All right, so that's what we can do. Now also, 10y and 6y, so I guess that's going to be 16y. So what I really have in here is negative 3y squared plus 16y minus 20, and then 15 plus 5y. So if I bring it over to the opposite side, so to this side, I'm going to get 0 equals 3y squared. Okay, so this 16 and then 5y. Now 16 is going to be negative, so it's going to be negative 16 plus the 5, which is going to be negative 11y. So those are gone. Bring this negative 20 over, so it's going to become positive 20, so 20 plus 15, which is 35. All right, and again, here we go. You get stuck with another quadratic. So from right here, once again, you can use your quadratic formula and then find out what the answer is. Okay, now I didn't mention it, but in this rational function, so please don't forget, because of the denominator, so notice y is not going to be allowed to be negative 3, because that would make it 0 there. And then from the other one, okay, so from here, if you would solve that, so you're going to get that y also cannot be equal to, and I guess that's going to be 10 over 3 right here, okay, because if that was the case, it would make that denominator 0. So it can't be those two. And now from here, once you manipulate it and get a quadratic, just use the quadratic formula, right? Now for us, I'm going to cheat a little bit, okay? So I'll just go right ahead instead of the quadratic formula, that you could use. I can plot it up into Desmos, okay? And let's see what we get. So now it's y, but I'm going to put x because Desmos likes the x's and right away graphs it for us instead of us creating some relation or function. So that's going to be 35. All right, so let's see. Sorry, I put y here, should be x. Okay, so there you have it. This is actually a parabola, and notice that there is no solution to this answer. So even if we found, or we tried to find or use the quadratic formula, we would run into a problem, okay, for this item. So that means under that square root, we probably would have a negative, okay, and then that would cause us some problems. And notice in here, the parabola does not go through the x, so it has no x-intercept, so there are no zeros here. So this has no solution. All right, so that's how you would solve that. Okay, so that's another example that you can run into, and it's beautiful that you can actually kind of check visually those zeros, okay, what would have happened. Now, if I go back to the last example, so this one looks way different, way harder, and it looks like it's not going to be a quadratic or something nice. So in those instances, you definitely will use some kind of a tool to try to help you. So let's see this last one and how we would solve this rational. So once again, we do have to worry. We have to make sure that this is not going to be a 0. So whatever x, okay, that would be. And then this, now this one is much easier to find. So from here, we know that x cannot be equal to, and I guess this is 2. And then from here, we would have to check when 3x squared plus 5x minus 2 is equal to 0. So we can check if, when that is undefined, okay, for us. And I can do that in kind of fast forward fashion, I guess. All right, so here you go. So these are the two zeros that we have to be careful with in terms of x. So x really cannot be equal to these. Now, taking it from there, so if I continue on, so maybe let me take this back and copy it, paste it in here. All right, and let's see what happens. Okay, so now once again, so with this one, what I'm going to do is I'm going to kind of cross multiply here. So we're going to get x and then x minus 2. Okay, so that's multiplying both sides. You know, basically this is what I'm doing, right? So that cancels that out. And then I'm doing the same thing. And this is going to cause an issue for us. So if I multiply both sides by the other denominator, I'm going to get that. And this is going to be a little hairy now, right? So we can simplify this. I can bring this inside here. So x squared minus 2x equals 2. And then now here, this is going to get annoying, but so be it. You've got to distribute across here. So 12, I guess, x cubed plus, this is going to be 20. This is x squared. And then minus, I guess, 8x. So that's first. Then the 2. So that's going to give me plus 6x squared plus 10x and then minus 4. All right, let's simplify this thing. Let's collect all of these different items. So 26x squared plus 2x. So negative 8. 10, so that's 2x minus 4, and then x squared minus 2x. All right, let's bring this over on the right hand side. So we're going to get 0, now 12x cubed. So I guess that's plus 25x squared, okay, because this is going to be negative. And then this is going to be brought over to the other side, so it's going to be positive, so that's 4x minus 4. So this is what we have right here, and it is a cubic. Now, sure, we can try to factor this out and then see what the zeros are. You know, you can play around, you can use the factor theorem or the remainder theorem, you know, to try to see, you know, how close you can get to the first zero. Then you can use long division for polynomials, right? And then it would give you a quadratic, okay, and a factor if it exists. Okay, so, you know, that certainly has been done. You know, if you've forgotten about the remainder theorem, okay, or factoring, I'll put that up above there so that you can work with those. Those were with respect to the remainder theorems in general. Now, I'm not going to do that because, to be honest with you, you know, when we do have tools like Desmos, we know that this is a cubic, right? So it's some cubic function, so we kind of know more or less, okay, and we can tell, you know, how it's going to cross through the zeros. So I'm going to literally just go right into Desmos instead of, you know, playing around and then utilizing, you know, factor theorems or remainder theorems. Okay, so I'm going to just go right in here. I understand that this is a cubic function. So in terms of a cubic function, so let's say 12x cubed plus 25x squared. All right, so it already looks kind of funky. So we have that, and then minus 4. Okay, so there you go. So there are 3 zeros here. Okay, one is right here, and notice they're ugly. So we, let's see if all of them were ugly. Yeah, I guess 0.31, so maybe that one is kind of the nicest one that we could have used, you know, utilizing the factor theorem and then checking it out by substituting it in there, okay, and then using the quadratic, okay, to solve for the other ones. But here we have our zeros right there, so I do encourage students, you know, utilize tools. The goal is for you to understand, you know, what you're trying to do. So in this case, you know, if you were able to use these tools, you basically, yeah, you can set, so this is, I guess, let's start, so 0.31, okay, x can be that, minus 0.5994, okay, you know, this is probably rounded in some way, that's okay. All right, so you have, you know, 3 of these, and then you can check, you know, which ones actually work and which ones do not. Now, don't forget that you can, of course, you know, if you substitute this back in, so this is going to be by the factor theorem, you know, it should give you a 0, right? So left-hand side should equal right-hand side, so you can kind of check if you're using a test or something of that nature. I do feel for you if you have to start solving these cubic or, you know, even quartic and so on, polynomials, and your teacher actually forces you to do that. But from my experience, what I find is you're not going to get something as ugly as this. You know, probably one of those factors is going to be a nice factor. And you can use what I mentioned with the factor theorem in polynomials in that video, which I was referencing in the beginning of this video. All right. So that's rational. Okay. Equations for you. You know, we have 3 examples here. They do get kind of hairy at times, but they're certainly doable. Okay, you have more than enough tools now to try to apply, and this is really not new. You're now just utilizing the tools you've learned from grade 9, 10, 11, and now since you're in kind of advanced functions, you can use those tools to solve such equations, okay, for yourself. All right, thanks for watching. We'll see you in a future video. Bye, everybody.